How's it going, everybody? Welcome to the channel Take and Make. I'm glad you're here. In this episode we're gonna open, set up and run our first test on this piece of machinery I just received from China. This is by far the most biggest and the most expensive addition to my workshop. Later in the video I'm gonna break down for you guys all the steps how I bought this milling machine on Alibaba. But first, let's get started on opening these packages. So this is gonna be our stand. I'm kinda disappointed it didn't come with any feet, so I'm gonna have to buy some adjustable feet so I can set this up in level. Hey guys, this is future me. I just forgot to mention in the beginning that this video has time codes, and if you wish to skip the review you can go directly to the machining. Also, most items I use, tooling, drill bits, Vises, ATC, everything is going to be listed down below in the descriptions. So if anything is catching up your attention, go down below and see if you can find it. Haha, I see my machine. This is the tray for cooling fluid. Ta-da! Check this beauty. Operating manual. Got some toolbox in here. 3 handles, wrench, screwdrivers, a wedge, and a chuck. And here we have electrical box. Alright guys, so the next step, I wanna put this stand on adjustable feet so we can set our mill in perfect level. To do so, I got this fancy leveling fit. And as well as inserts with M12 thread on it. An idea is to put this in the bottom of the stand, weld it through those 3 holes, and then I can put my foot and adjust all 4. So let's go ahead and do that. It may be a bit overkill, but I decided to weld around all 4 inserts. Better be safe than sorry. This machine alone is 330 kg. Okay, now we can go ahead and screw these feet. So now I think I can save some time if I level the feet first while it's upside down. So in theory, if I make them level this way, it should be level when I put them right side up. That's level. Now we do this side. That's level. What about this way? Level. And go a little bit. Yes. Now we're gonna put it right side up and see if I was any close. And the moment of truth. No, it's not. It's very close, but not quite. Front is pretty close. I'd call it good. This is also very close, and that's not too bad. So I'm just gonna adjust this side a little bit. There it is, guys. Stand installed, no play. Pretty satisfied. We ready to lift this bad boy and set it up on its pedestal. I got my good friend Jimmy, my neighbor, as well to help me lift this piece on the pedestal, and he's kind enough to borrow me his engine lift. So we yet to figure out if it's strong enough to lift it. What do you think, Jimmy?
Yeah, we're about to find out.
Also, we don't have like an actual strap, so I found like a piece of ratchet strap or whatever. I'm just gonna tie a knot, and hopefully it's gonna hold.
Right. Are you wearing steel toes?
No.
Neither am I.
Okay. How do we do this?
It's kind of crazy with the pallet. It's almost like it needs to be shifted forward a little bit first. Oh, there we go.
Hold on. Yeah, I just hold it till you will get some tension. I actually need those bolts. I think if we drop it like that, then we can put strap on the bottom. Oh, dude. First off, we can shorten this.
Yeah.
I used crescent wrench today. It's kind of tough to find anything in this mess. I have another one here. This is still not enough though, eh? If we lift here.
You want to see if
Oh, dude, this goes down. I completely forgot this goes down. We might be lucky. Let's see if it's even gonna be high enough. Come on, baby. Yeah, I think so. Looks close.
Lower it.
Yeah, try to lower it a little bit.
Shit, sorry. That was way too quick.
This one's in. Yeah, go down a little bit. Or are we out of...
That'll be perfect. Good. Let it down. Okay. I say you bolt it, and then we realign it 20 inches from the wall after you get it bolted in.
Well, there it is, guys. The mill set on the stand, and it looks awesome. Thanks again for helping Jimmy. First thing we're gonna do, let's install some handles. Okay guys, it took me some time to run new electrical wire to this wall. It's right here behind me. Now we're gonna plug this milling machine for the first time. It's on here. On here. Okay guys, so I played with the controls a little bit and it's not super hard. This on the left is feeding for auto feed and auto top. This one is pretty obvious, you get to the height you want, and then this handle gives it micro adjustments, but it has to be shifted to the right, and then it gives you those micro adjustments. When you're done, you lock and mill away. $2,500, almost $2,600 is the max. It is pretty loud on maximum speed. Fully stop, we can switch the first gear and our maximum speed will be only 560 RPM. Okay, I say let's figure out how to remove this taper for drill chuck, and we're gonna install R8 ER 32nd chuck so I can try a bit of mills that I already purchased. Which one allows you to change bits pretty quick, and you can buy all sorts of inserts to go in here for different size mills. So we're gonna give this one a try. Let's go ahead and install it. That wasn't too bad. I got this 3/4 inch mill for rough milling. I'm gonna run my first test with this mill. Now we can turn it on and see how well it spins. That looks pretty good. Right on. I'm itching to mill something. Next step would be to peel this piece of paper, wipe all this grease, and install our vise. There's lots of different varieties of devices on the internet, but so far I'm learning, and I didn't want to buy nothing expensive, like cord Vise for instance. It's like $1,000. So I went with this Weaver 6-inch milling Vise, or is it 5? No, it's 5 Aculock machine Vise. Let's open it up and see what it is. Holy moly! Ooh. That is pretty heavy. Comes with a couple T-bolts and 2 nuts. I think I'm gonna install it on this one. Okay, let's throw first chips. Our first victim will be a piece of 3/8 brass. Now for the speed. How to determine how quick I should spin this. There's multiple tables online. I'm not gonna explain it in details, but surface fit per minute for brass is around 300. So 300 times 4, divide by the diameter of our tool, 3/4, which is 0.75, equals 1600 RPM. That's how quick I should spin this mill. Piece of cake. The whole mill was working. It's funny, it looks like a pack of staples, if you know what I mean. But this finish, when you work it as a face mill, man, that looks nice. Okay guys, I know it's a waste of material, if you will, but I just want to see the capabilities of this end mill, and I'm gonna mill like an inch, maybe 1.25 inches of that brass piece in one go. Hot to touch, but nothing too crazy. Yeah, this end mill chewing through brass, no problem. Well, let's see what we can do on the mild steel. So following our formula, 3/4 inch mill for mild steel is 533 revolutions per minute. So we're gonna put like 550. Just gotta go a little quicker. Cuts nicely. Man, this is sweet. And cool to touch. Wow, this is truly an amazing tool. Let's try to mill down and make all that square. And that's done. And finish is quite alright. It's not polished, but it's good. Definitely a pass for this end mill. And the milling machine in general. I think I took some thick cuts. What do you guys think? Not bad of the finish at all. Okay guys, so the next cutter I want to try is 2-flute, and it's designed for plunge cutting. We're gonna lower the cutting bit right through this piece of brass, and then we're gonna start milling sideways. See how that goes. Wow, that was fun. The only thing not fun, I milled a little bit of my Vise. Okay, let's see if we can do some damage to steel again. Alright guys, so I got a piece of 1/4 inch thick, 1.5 inch square tubing. Let's see how this end mill will perform on that. Yeah, that's a little too much for this machine. It's shaking. But we made a cut through it. 1/4 inch mild steel. I wonder how big of the damage we can do to aluminum now. I probably should have started with aluminum, then go brass and then mild steel. But I wanted to go hardcore kinda right away, see if I be able to mill some steel. Okay, we'll leave aluminum for later. We're gonna switch our cutter to face mill. This is 1 5/8 of an inch face mill with carbide inserts. Let's set this in mill and see if we can face mill something. Our piece for face mill would be this 1/8 1x2 square piece of tubing. Let's figure out our speed. It's 1 5/8. 246 revs per minute. I'll switch to first gear. Yeah, that's a little too crazy. Let's check it out. Yeah, I gotta read a little more information on the feeding speed, but I figured the slower you go, the better the finish. Maybe I can increase speed a little bit. Looks pretty cool. I really enjoyed throwing chips, man. And be able to leave a surface finish like this for some application, dude. That's nothing wrong with that. Love it. Alright guys, so let's talk numbers for a little while. I bought this machine on the Alibaba site. I'm sure most of you have heard of it. Okay, so we're gonna go to search bar and we're gonna put ZAY7045 drilling milling machine. There is a multiple suppliers which sell clones of this machine, like dozens. Go ahead and message at least 3, 4, 5 of them. Get a quote for how much they're able to sell it to you, and get a quote on shipping as well. I ended up buying my machine from WMT CNC Industrial Corporated. They gave me the best price on it and also good deal on shipping. So yeah, this is our machine here, ZAY7045V/1. There's lots of varieties of it as well. There's FG, V, C, whatever, and they all differ a little bit. Mine has VFD and digital speed control with 2 manual speeds. This is kind of way to go for me. As for the price, this is what I ended up paying. Milling machine, $1,670 US. I also got machine stand for $110, and shipping costed me $960, which brings total to $2740 USD delivered right to my home. Judge for yourself, guys. Is it too much? Is it good deal? I figured that's a good deal. I will leave you a link in the description to this particular seller so you can check out the pricing and stuff. So just some food for thought for you guys, and we're gonna go back to testing. And to continue our testing, we're gonna test auto drill and auto top functions for this mill. I'm gonna drill and top 3 common sizes: 1/4 inch, 3/8 and 1/2 inch in mild steel, and we'll see how it performs. So there's a different chart for drill speed and material and bit thickness. I'll try to put it on the screen, but you could easily find it online. So for 1/4 inch bit, for mild steel, we're looking for 1120 to 1330 revs per minute. So I'm gonna go with 1200 revolutions, and let's try to auto drill this. Couple things I wanted to mention. So to be able to top on milling machine, you need to buy special tops. I tried to do it with manual tops, it doesn't work. So don't repeat my mistake and get yourself a special tops for milling machine. Could be spiral tops like this or other kind. Do your research. Also, my tops didn't come out great because this chuck is absolutely horrible. You can see it in this video how absolutely off-center it is. So now this is history and complete junk. I got me a keyless chuck with R8 shank, really good quality. I'll leave you a link in the description. So let's install this bad boy and see if we can get better tops. Alright, I set the chuck up and I put this indicator, dial indicator on it. Let's see if there's any needle movement. It jumps like almost 3,000 of an inch, which makes me believe that this is mill problem, or I'm not doing it right, because this is first time I'm setting up this dial indicator. Faster I go, yeah, it's in the range of 2000s. I pick another spot on the chuck and it jumps a lot less, within 1,000 of an inch. Alright, so we're gonna cut a thread in 3/4 inch aluminum. And I also wanna test my freshly bought parallels, precision parallels. So we're gonna test all three bits: 1/4 inch, 3/8, and 1/2 inch. See how this keyless chuck works. Oh man, truly does. Okay, you ready guys? Let's stop this hole. Top came loose. Next one, 3/8. Now we'll do 1/2 inch one more time. I don't know about you guys, but they look like nice and crisp threads to me. Let's see if we can put a bolt in it. Help it with a little bit of wrenching. Look at that. No play at all. 1/2 inch thread in 3/4 inch material. I'd say it's pretty good. Okay, I say aluminum pass. Let's see what damage we can do to steel. Okay guys, let's see, top in 3/8 hole and looks like a little less than 1/2 inch piece of steel. We'll do 1/2 inch now. So for drill bits, I can tighten this chuck by hand But if we install a top in it, there's way too much friction going on and it sleeps. So I figure when we top, it's technically keyless chuck, but it has a key still, and we want to use it to make it real tight. No problem. Wow. Let's inspect it. These parallels are super handy. I don't regret I bought them. We're gonna try 3/8 first. Nice and tight, man. Really nice threads. Look at that, 1/2 inch goes with no wrench. This is definitely a pass. Okay guys, what can I say in the conclusion? There is absolutely no way that this cheap mill can compete with high precision, expensive brand names. But for a shop like mine, where I'm just getting into machining and not looking for high precision operations, that's a good alternative for expensive stuff. Overall, I'm pretty satisfied with what I have. I'll keep using it and maybe make another review year or two after, once I learn more in machining and I could really reveal the potential of this Chinese mill. For now though, I'm pretty happy owner of my first piece of machinery, and next I'm planning to get a lathe. Thank you very much for every one of you who made it this far to the end of the video. I really appreciate it. If you like it, please give me a thumbs up and consider subscribing to my channel. There's gonna be lots of interesting content in the future. That's it for this one, and I will see you in next one.